Hey guys, today's March 15th, and I'm going to do another LeetCode Daily challenge. I haven't been doing so hot lately with these problems, and the topic has been binary search, so maybe this problem today is binary search. We'll see. Okay. Um, 2594, minimum time to repair cars. You are given an integer array ranks representing the ranks of some mechanics. Ranks I is the rank of the ith mechanic. A mechanic with a rank R can repair n cars in R times n squared minutes. Okay. You are also given an integer cars representing the total number of cars waiting in the garage to be repaired. Return the minimum time taken to repair all the cars. All the mechanics can repair the cars simultaneously. Ranks 4, 2, 3, 1, cars 10. The first mechanic will repair 2 cars. The time required is 4 times 2 times 2, which is 16. The second mechanic will repair 2 cars. The third mechanic will repair 2 cars. 3 times 2 times 2. And the fourth mechanic will repair 4 cars. It can be proved that the cars cannot be repaired in less than 16 minutes. Okay, so I'm a little bit confused. Like, I'm just not really thinking right now. But what I learned from yesterday, and like I'm starting to see this pattern of, um, it's kind of like a number line, let's just say. And the whole idea of this binary search and when we should use it is we are going to have some like result, right? Like the minimum time taken to repair the cars is the minimum time 0, or is it, let's just say, like this far number n. At some point there's going to be a minimum time, right? And let's just say that that point is right here. So that means it's like, oh, can we repair these cars? Yes. So I'm going to say like a y for yes. That means since it's the minimum time taken to repair those cars, that means anything to the right of it or anything that takes longer time will for sure be able to be repaired. And since this point is the minimum time, anything to the left of it is going to not be able to work. So once you have some sort of problem that kind of breaks down like this, then you can use binary search to find the minimum. So that's what I learned recently, and I think we could definitely apply it to this problem. But this whole like 4 times 2 times 2 thing, I'm still a little bit confused. But we'll see. Yeah, because I don't know what the maximum, or like I don't know what my left and right should be. That's something like with these binary search problems, we need to choose what our left and right would be. But for now, I'm just going to say we're definitely going to be using binary search, and that's about it. Okay, so let's do an example then, because I'm still a little bit confused. 518 cars is 6. So what does cars mean again? Cars is the total number of cars waiting to be repaired. The first mechanic will repair. Okay, so the output is 16. The first mechanic will repair 1 car. That's 5 times 1 car times, oh, because it's 1 squared. So these are just like squared. Interesting. The second mechanic, so that will give us 5. The second mechanic, 1 times, can repair 4 of them. 4, which is 16. Third mechanic will repair 1 car. The time is 8 because 8 is right here. And then he could do 1. So 1 plus 4 plus 1 is 6. So that's the 6 cars right here. Yeah, okay. I guess that's what we'll do. Yeah, sorry, I was just really blinking for a sec. It's a slow day for me. But I think that's all we're gonna do. Just binary search. Um, so we could have a def. We kind of want to create a function that will take some input and it will spit out if it works or not. So def like can finish, like can we finish repairing all the cars? It's going to return some sort of boolean, and then that can be, it will take in the minimum, right? It will take in the answer, minimum time. So let's just do min time right here. Or I'll just say target time. So then now we actually do the binary search aspect, left, right. Left is going to be 0. Oh, that's one thing I don't know what right should be. Maybe right would be the minimum. The minimum squared times the cars. Oh, no. Minimum times the cars squared. So minimum of the ranks times cars squared. There we go. That's our left and right. And then now we just do binary search, or I guess we can have a result, which is none, while left less than or equal to right. Mid is left plus right minus left over 2. If can finish with the mid, then our result can be mid. If we could finish, it was yes, so let's search to the left. So right is equal to mid minus 1, else left is equal to mid plus 1. After all this, return the result. I think it's guaranteed that we'll find an answer for sure, right? So no need to check if result is none or not. Okay, so now the hard part, or the bulk of the problem, is what is going to be in our can finish. So we have a target time. And let's just say that target time was like 16. So let's see. We want to choose something less than 16, right? Less than the target time. So we definitely need a loop for rank in ranks. What is it? So it's going to be like rank times some sort of x squared, right? Rank times x squared has to be less than or equal to target time. We don't know what x is, but we do know what target time is. So I think I need to oh, can I divide the rank over? So x squared. Wait, I haven't done math in a while. Wait, so it's the rank times some sort of unknown value is equal, like less than or equal to, does it matter? Less than equal to our target right here. So we don't know what x is, but we do know what the rank and target is. So I could divide by rank, and then I could divide by rank. So x is less than or equal to the target over the rank. That should be x squared. And then I think we can just square root both sides, right? So x is less than or equal to target over the rank. So that's going to be our count. Wait. Yeah, okay, that's our count. So count plus equals to square root of target time and target time divided by rank. Do we do integer revision? That's something I don't really understand, or I don't know, but we'll do that. And then we could just return the count. We wanted to have repaired these cars, right? So was the count greater than or equal to the cars? So I think that's it. Let me go ahead and run that. Wrong answer. Okay, wait, sorry, 1 second. Girl, come here. Okay, what is going on? Wait, so let's just say we were on 5. Okay, let's just say we were on 5 as our rank, and the target time was 16. So what I'm doing here is I'm taking the square root of the target time divided by the rank. So 16 divided by 5 is 3, right? So the square root of 3 is 1. Let me go ahead and print this out though. So it might be giving me decimals. Okay, it's giving me decimals. I think I need to round down, so I just turn it into an int. Something like this. Let me go ahead and run it again. Okay, cool, yeah. So that worked. Let me just submit that. Awesome. I mean, yeah, like this problem's cool. I'm like, my brain's not working super well today. But with that being said, it's cool that we've been doing this same like binary search approach the last couple of days. So getting to this like number line or like getting to this approach in my head wasn't super hard, right? I was like, oh, there's definitely like a number that they're looking for, which is the minimum time. So why don't we just binary search, try to find this minimum time? Because there's going to be a point where if we pass the minimum time into this can finish function, it's going to return true. So the very first occurrence of that is going to be our minimum time. So that's, yeah, that's pretty straightforward. I was really slow coding it, but hopefully I'll get faster. Time complexity, so log n, right? N is just the, whatever this is. So I'll just say log n, and then that's just going to be linear. So I just do n log m, where n is the length of the ranks, and m is the like minimum of the ranks times the cars squared. Yeah, so that's the time complexity, and then space is just constant time O1 because we're not really storing anything else besides these pointers. So yeah, hope you guys enjoyed the video and see you tomorrow.